Today we are going to talk about errors of measurement. So we are going to talk about errors of measurement. Whenever you're measuring something, no matter how accurate your device is or how precise your device is, it's not actually going to give you the correct reading. There's always going to be error. So what we try to do, we always try to minimize error. So before learning how to minimize error, we actually have to understand what is error. So to understand the error, we will have to understand its types and how to find them. So let's write it, which is the definition, the difference in the true value, so the actual value, and the measured value, and the measured value of a quantity is called error is called error of the measurement. Error of the measurement. So basically we are seeing the true value and the measured value. So think about it. Suppose there was a rod which was 20 centimeter in length, but when I measured it, I found out that it was 21 centimeter, which is a fair estimate to be wrong by. Suppose it was exactly 20 centimeter and I measured it from my best of my abilities and got it to 21 centimeter. Suppose then so now subtracting the true value from the measured value, sometimes measured value is also written as observed value, so this will actually give you with minus 1 centimeter, which is our error. So you might think, what does the minus signify and what does minus 1 centimeter mean? So it means that if you subtracted 1 centimeter from the value that you originally had, so if I subtracted 1 centimeter from the value that I originally had, it will give me the true value. So it just gives a link between the measured value and the error, and the true value, it gives a relation. So we will talk about this later on, but before that, let's talk about types of errors. So the first one that we're going to talk about is systematic error. Systematic error. There are various categories of defining error. I'm only gonna choose a few of them, which I found describes a lot of errors. So it arises, systematic error arises due to known causes, like due to calibration, due to calibration of instrument, lack of accuracy, and a lack of accuracy of formula, used for the measurement, etc. So these errors, so the errors due to calibration and lack of formulas, can actually be fixed. So also this error cannot be minimized, but you might think, how can it not be minimized? If you just think about it, if I calibrated my instrument and I had a accurate formula, then this could be minimized. So if this error cannot be minimized by repeating. So the important point is by repeating by repeating the observations the observations. So that's the important point. This error can't be minimized by repeating the observations. You can minimize the error by calibrating the instrument and having a much more accurate formula used for the measurement, but it can't be minimized by repeating the measurement. Suppose I did 100 experiment, it will still there will still be this error and it will not decrease. But if I calibrate my instrument, so and I use a more better formula which is more accurate, then I will see that the error will be minimized. So another kind of error that you must know, which is known as random error. Random. So let me write random error. So the name is sufficient enough, but let's write the definition to make it much more clear. It arises, so random error arises due to unknown cases. Example. So the unknown cases, the examples of some unknown cases are pressure, temperature, humidity, mechanical vibrations, etc. This error can be reduced by taking a large number of observations, and finding the average value. So random error occurs due to unknown cases. The unknown cases may be anything that you haven't accounted for. For example, in the formula, it's not random because you were the one who decided the formula and you were the one who calibrated the instrument. But things like pressure, temperature, humidity, mechanical vibration generally can't be controlled. You can find out what it is, but you can't control it in a very precise setting, or if you go to big labs, of course you can control it, but for our case we can't. So these are unknown cases. So these are caused by the unknown cases, and which is why this error can be reduced by taking a large number of observations. So you might think, why large number of observations? Because think about it. Let's do an experiment where we are talking about sound. For example, think about it. If someone screamed in one experiment, it was dead silent in another experiment, it was somewhat chatty in the next experiment, there are random variables. Just think about it. If you were, suppose there were 5 people doing an experiment on the sound. So in the first experiment, everyone was dead silent. In another experiment, someone sneezed. In the third experiment, someone, like two of your friends were talking. Then looking at the individual data, you will find that it's not the same. It varies due to the unknown cases that were the talking, that somebody did, sneezes and stuff like that. But you take the average, you will get a pretty good approximation. And the larger observations you take, you will get better and better observations, a better and better average value which matches the true value. So random error is, I think you understood it, but if you didn't, I don't know how to explain it. Let me explain it much better. A random error is pretty clear from the name itself, so I don't think I have to mention much more. So now let's talk about absolute, relative, and percentage error. So when talking about them, So these are three terms related to error. So let's first of all talk about absolute error. Absolute error. So when we talk about absolute error, we are looking at what is the actual error? What error do we actually get? So think about it. So it's the true value minus the observed value. So we also did an example back then of 20 centimeter, but let's write it again. Suppose I had a rod of 20 centimeter, which is the true value, and I found that the rod was 21 centimeter, then the absolute error will be minus 1 centimeter, which means if I subtract 1 centimeter from my observed value, I will get the true value. So this is the absolute error. It is the actual error that has occurred. And the second one that we are going to talk about is relative error. So relative error. Whenever the word relative comes up, when we're talking in physics, so when we're talking in English, it might be someone of that but when we're talking about physics, it's always to respect of something. So respect of what? It's generally to the respect of something that you're trying to measure. So we are trying to measure the true value, right? Since we're trying to measure the true value, our absolute error will be this, but the relative error will be with something with this divided by the true value, because we're trying to see what is the change that we're actually searching for. So for example, so let's just make this. Suppose I had a true value was 100, and let's say 200, the true value was 100 centimeter. The observed value was 90 centimeter. So when you measured, you got 90 centimeter, and divided by the true value, it will still be 100 centimeter. So with this, you get 10 by 100, which is 1 by 10, or 0.1. So see, when we're talking about absolute error, the unit comes up. So when we are talking about the absolute error, unit comes up. But when we're talking about relative error, the unit does not come up. So there is no unit right here. So it tells us that the error is 0.1% of the original value. So we have 100 centimeter. So if you multiply it by 0.1, you get the error, which is pretty simple to understand. Since you multiply, if you take this part, which is the true value, you get that this relative error times the true value gives you the error. So the true value times the relative error gives you the error, the absolute error. So the relative error does not have a unit as well. So it's just giving you how much is the value deviated from the true value. And finally, let's talk about percentage error. The word percentage makes it clear that we are going to talk about percentage. And when we're talking about percentage error, so when we're talking about percentage error, it's going to be relative error. So relative error, this is relative error times 100%. So basically, this is almost basically the relative error expressed in percentage, because if you know 100% is 100 by 100, which is just 1. So it's TV minus OV by TV. So true value minus observed value by true value into 1, which will just be this. So this is relative error. So if you express relative error in terms of percentage, it will actually give you the percentage error. So let's take the previous example where our true value was 100, observed value was 90. So that's a centimeter, 90 centimeter, and the true value divided was 100 centimeter into 100%. This gives you 10%. So this 10% means that, so this 10%. So let's go back. Here is 0.1. So here you know that if you multiply the relative error times the actual true value, you get the error, but the absolute error. But here you have the in terms of percentage. So if you multiply this with this, you still get the relative error in percentage. So I hope this is pretty clear to understand. I think this is pretty clear to understand, because think about it. we have 100, which is the true value, and 90 is our observed value, which means that there is a 10% error since we have 90. So that was it for today's video. In the next video, we are going to talk about combination of errors. Till then, bye bye.